force, right? When there is a resultant force, when there is a resultant force on the object, what is the resultant force? Force by the weight, right? So there's a resultant force on the object. There's going to be acceleration in the direction of the resultant force. In the direction of the resultant force, right? Therefore, object is going to accelerate and object is going to speed up. Object is going to speed up. When objects speed up, there is a force called air resistance that will slowly develop. Starting from zero, air resistance will slowly start to increase, start to develop, right, on the object. So after certain time period, you can see there is a force acting downward, which is your weight. It's anyway there. But on top of that, there is a opposing force called for resistance, air resistance, that has developed on the object because the object has gained speed, because the object has speeded up. Therefore, at a certain distance, after certain time period today, you can very clearly see the object is experiencing a opposing force called air resistance. Furthermore, you can see this air resistance. This air resistance has increased to equalize with your downward force, which is your weight. It has increased to equalize with the downward force, which is your weight. So at that point, if you see the forces acting on the body, there is weight acting downward, there is air resistance acting upward. So this is a scenario where we understand forces are balanced. Forces are acting opposite, and then forces are balanced. When the forces are balanced, what is the result? There is no resultant force. When there is no resultant force means there is no acceleration. When there is no acceleration, there can be two outcomes. One is object is stationary. Second one is object is moving at constant velocity. In this scenario, what is applicable is the object is moving at constant velocity. So this maximum constant velocity that is reached as a result of forces acting on this free falling body being equal to each other. Or in other words, this maximum constant velocity that this free falling object achieves or acquires as a result of resultant force on this body becoming zero. Why? Weight acting downward is now equal with the upward air resistance, which has developed from zero as the object is speeding up. This is called a self-adjusting force. Air resistance is called a self-adjusting force because it can start from zero and increase as the velocity is increasing, as the speed is increasing. Are we clear? So that maximum velocity that is acquired by this object, right, as a result of your self-adjusting air resistance being equal to the weight acting downward, the maximum velocity is what we understand as terminal velocity. Is what we understand as terminal velocity. This object will continue. This object will continue, right? This object will continue to fall under this terminal velocity until it reaches the ground. So this is what we understand as terminal velocity. Are we clear? So
Yes,
the
sir.
object is falling from rest. So we call initial velocity is zero. It is falling from imagine it is falling from a very high elevation. A parachute is jumping from a plane, or maybe a skydiver jumping out of a plane. So we call this object falls under gravity. It's freely falling. So we call it free falling objects. Initially, the only force acting on this body is the body weight, which is acting towards the earth, downward towards the earth. And air resistance on the object is initially zero. Air resistance is initially zero. Right? Therefore, on this object, there is a resultant force acting downward. Right? There's a resultant force acting downward, which is caused by your weight, W. So this resultant force will cause this object to accelerate towards the earth. During this acceleration, you can clearly see the speed is building up, speed is increasing. As the speed increases, you can see air resistance slowly develops. Air resistance slowly increases because air resistance is a self-adjusting force. Air resistance is a self-adjusting force. And it comes to a position, it comes to a point, this air resistance increases, and it comes to a point, it equalizes with the downward weight. It equalizes with the downward weight, causing a resultant force zero case, causing resultant force zero on the object. When the resultant force is zero, acceleration becomes zero, and this object reaches a constant velocity, which we will understand as terminal velocity. The object will continue to fall at this terminal velocity until it reaches the ground. Until it reaches the ground. One importance of this terminal velocity is that free falling objects will reach the ground at a controlled speed. At a controlled speed, it will not accelerate to very high values by the time it reaches the ground. If that happens, what happened to them? If that happens, what happened? They will always try to damage these objects. It's always try to damage these objects, and it's very difficult. It will be very difficult to control the landing of these objects. So that's a natural advantage that we have because of terminal velocity. So I hope you guys are clear on terminal velocity.